In the 1960s, the Advanced Research Projects Agency, ARPA, of the United States Department of Defense, DoD, funded research into time-sharing of computers. J.C.R. Licklider proposed the idea of a universal network while leading the Information Processing Techniques Office, IPTO, at ARPA. Research into packet switching, one of the fundamental Internet technologies, started in the work of Paul Baran in the early 1960s and, independently, Donald Davies in 1965. After the Symposium on Operating Systems Principles in 1967, packet switching from the proposed NPL network was incorporated into the design for the ARPANET and other resource-sharing networks such as the Merit Network and Cyclades, which were developed in the late 1960s and early 1970s. ARPANET development began with two network nodes which were interconnected between the University of California, Los Angeles, UCLA, and SRI International, SRI. On 29 October 1969, the third site was at the University of California, Santa Barbara, followed by the University of Utah. In a sign of future growth, 15 sites were connected to the young ARPANET by the end of 1971. These early years were documented in the 1972 film Computer Networks, The Heralds of Resource Sharing. Thereafter, the ARPANET gradually developed into a decentralized communications network, connecting remote centers and military bases in the United States. Early international collaborations for the ARPANET were rare. Connections were made in 1973 to the Norwegian Seismic Array, NORSAR, and to University College London, which provided a gateway to British academic networks, forming the first international resource-sharing network. ARPA projects, international working groups and commercial initiatives led to the development of various protocols and standards by which multiple separate networks could become a single network or a network of networks. In 1974, Bob Kahn at DARPA and Vint Cerf at Stanford University published their ideas for a protocol for packet network intercommunication. They used the term Internet as a shorthand for Internetwork in RFC 675. And later RFCs repeated this use. Kahn and Cerf credit Louis Pouzin with important influences on the resulting TCP/IP design. National PTTs and commercial providers developed the X25 standard and deployed it on public data networks. Access to the ARPANET was expanded in 1981 when the National Science Foundation, NSF, funded the Computer Science Network, CSNET. In 1982, the Internet Protocol Suite, TCP/IP, was standardized, which permitted worldwide proliferation of interconnected networks. TCP/IP network access expanded again in 1986 when the National Science Foundation Network, NSFNet, provided access to supercomputer sites in the United States for researchers, first at speeds of 56 kilobits per second and later at 1.5 megabits per second and 45 megabits per second. The NSFNet expanded into academic and research organizations in Europe, Australia, New Zealand and Japan in 1988–89. Although other network protocols such as UUCP and PTT public data networks had global reach well before this time. This marked the beginning of the Internet as an intercontinental network. Commercial Internet service providers, ISPs, emerged in 1989 in the United States and Australia. The ARPANET was decommissioned in 1990. Steady advances in semiconductor technology and optical networking created new economic opportunities for commercial involvement in the expansion of the network in its core and for delivering services to the public. In MID 1989, MCI Mail and CompuServe established connections to the Internet, delivering email and public access products to the 500,000 users of the Internet. Just months later, on 1 January 1990, PSINet launched an alternate Internet backbone for commercial use. One of the networks that added to the core of the commercial Internet of later years. In March 1990, the first high-speed T1.15 megabits per second link between the NSFNET and Europe was installed between Cornell University and CERN, allowing much more robust communications than were capable with satellites. 6 months later, Tim Berners-Lee would begin writing World Wide Web, the first web browser, after 2 years of lobbying CERN management. By Christmas 1990, Berners-Lee had built all the tools necessary for a working web. The Hypertext Transfer Protocol, HTTP 0.9. The Hypertext Markup Language, HTML. The first web browser, which was also an HTML editor and could access Usenet newsgroups and FTP files. The first HTTP server software, later known as CERN HTTPD. The first web server, and the first web pages that described the project itself. In 1991, the Commercial Internet Exchange was founded, allowing PSINet to communicate with the other commercial networks CERFnet and Alternet. Stanford Federal Credit Union was the first financial institution to offer online Internet banking services to all of its members in October 1994. In 1996, OP Financial Group, also a cooperative bank, became the second online bank in the world and the first in Europe. By 1995, the Internet was fully commercialized in the U.S., when the NSFNet was decommissioned, removing the last restrictions on use of the Internet to carry commercial traffic. As technology advanced and commercial opportunities fueled reciprocal growth, the volume of Internet traffic started experiencing similar characteristics as that of the scaling of MOS transistors, exemplified by Moore's law, doubling every 18 months. This growth, formalized as Edholm's law, was catalyzed by advances in MOS technology, laser light wave systems, and noise performance. Since 1995, the Internet has tremendously impacted culture and commerce, including the rise of near-instant communication by email, instant messaging, telephony, voice-over Internet Protocol or VoIP, two-way interactive video calls, and the World Wide Web with its discussion forums, blogs, social networking services, and online shopping sites. Increasing amounts of data are transmitted at higher and higher speeds over fiber optic networks, operating at 1 gigabit per second, 10 gigabits per second, or more. The Internet continues to grow, driven by ever greater amounts of online information and knowledge, commerce, entertainment and social networking services. During the late 1990s, it was estimated that traffic on the public Internet grew by 100% per year, while the mean annual growth in the number of Internet users was thought to be between 20% and 50%. This growth is often attributed to the lack of central administration, which allows organic growth of the network, as well as the non-proprietary nature of the Internet protocols, which encourages vendor interoperability and prevents any one company from exerting too much control over the network. As of 31 March 2011, the estimated total number of Internet users was 2.095 billion, 32% of world population. It is estimated that in 1993 the Internet carried only 1% of the information flowing through two-way telecommunication. By 2000 this figure had grown to 51%. And by 2007 more than 97% of all telecommunicated information was carried over the Internet.